Hello and welcome to this video. My name is Keshav Jadhav, and in this video I will explain how to draw isometric view from given orthographic views of simple objects. So in this video I will explain how to draw isometric views of simple object like this. So a question will be like this: draw isometric view from given orthographic views of object by first angle method of projection. So these orthographic views are given as per first angle method of projection. So this is the front view and this will be the top view. And from this we have to draw isometric view. Isometric view, it is the three-dimensional view of the given object. So for this front view and top view, I have explained step by step how to draw isometric view in another video, and the link of that video is given in description of this video. In this video, I have explained basics of isometric projection and how to draw isometric view of simple objects like rectangle, cylinder, etc. So first we will see what is isometric scale. So let us draw a horizontal line AB, and by using protractor draw line at 30 degree inclination and 45 degree inclination. So line AC it is at 30 degree inclination and line AD it is at 45 degree inclination. Now by using scale we can mark the points on AD line. So this will be the true lengths, that is 10, 20, 30, 40 mm like this. Now from these points draw vertical lines like this. So these vertical lines will intersect line AC which is at 30 degree inclination. So we can mark these points like 10, 20, 30, 40, 50 etc. So lengths on AD it is the true lengths, and respective lengths on line AC it is isometric lengths. Now let us see difference between isometric view and isometric projection. So let us consider this orthographic view, and for this orthographic view if we use true lengths to draw isometric view, then we will get object like this. So here to draw this isometric view we have used actual lengths. Now we can draw isometric drawing by using this isometric lengths. So we will get similar object, but its dimension will be reduced dimension. So instead of using this true lengths, we can use lengths on this line AC, or we can multiply to this true lengths by factor 0.816, so that we will get isometric lengths. So by using this reduced lengths, if you draw isometric drawing, then it is called isometric projection, whereas if we use true lengths to draw the isometric drawing, then it is called isometric view. In this video we will consider true lengths, means we will be drawing isometric view from given orthographic views. So let us see how to draw isometric view for given orthographic views. So orthographic views are given as per first angle method of projection. So this will be the front view and this will be the top view. So first we have to visualize three-dimensional view of the given orthographic views. So there is one object which will look like a rectangle when we look from the front side, and when we look at the same object from the top side, then it will look like another rectangle of dimension 40 by 20. So let us consider three-dimensional rectangle in the front view, and it is extended by 20 mm in front direction, that is perpendicular to this rectangle. So it will look like this. So when we look at the object from front side, then we can observe the front view rectangle, and when we look from the top side, then we can see the top view rectangle. So in this way, from given front view and top view, we can visualize three-dimensional object. Let us understand step by step how to draw isometric view of this rectangular block. So draw a horizontal line and take point O on that horizontal line, and then by using protractor draw 30 degree inclination on right side called x-axis, 30 degree inclination line on left side which is z-axis, and vertical line which is y-axis. So these are the x, y, z axis, and this axis called isometric axis. So whatever the vertical and horizontal lines are there in front view and in top view, those lines will be parallel to this isometric axis, and those lines are called isometric lines. So in given orthographic view, here this is the point O. This O point means this point, and in top view that O point will be here, and here we have to draw the isometric view. So this point will be the origin O. Now let us start from the front view. So from O on right side there is one horizontal line. So from point O on right side there is x-axis. So we can draw this line along x-axis. So length of this line is 40 mm. So by using scale we can measure 40 mm distance and draw a line like this. Then there is one vertical line from point O. So we can draw a line along y-axis and its length will be 60 mm. So we can measure 60 mm length and draw a vertical line like this. Then from this end there is horizontal line like this. So this horizontal line is parallel to this line. So this line already we have drawn along x-axis. So we can make roll and draw parallel to x-axis and draw parallel line from this end, and length of that line it is 40 mm. Then there is vertical line like this which is parallel to this vertical line. So make roll and draw parallel to y-axis and draw vertical line which will connect these two ends. So its length will be 60 mm. So in this way we can complete the front view in the isometric view. So as front view it is placed on right side of point O, this front view rectangle will be on right side in the isometric view also, that is in xy plane. And as we have to draw isometric view, we are using the true scale. Now let us look at the top view. So when we look at the object from the top side, this side it is the right side of O and this will be the left side of O. So from O point on right side there is 40 mm length line, and this line we have already drawn while drawing the front view rectangle. Then there is a 20 mm line on left side of O. So here from O on left side there is Z axis. So along Z axis we can measure 20 mm distance and draw a line of length 20 mm. Then there is horizontal line which is parallel to this line. So this line we have already drawn here along x-axis. So we can make roll and draw parallel to x-axis, and from this end we can draw a line parallel to x-axis and its length will be 40 mm. Then we can connect these two ends. So this line it is parallel to this line. So this line we have drawn along z-axis. So we can make roll and draw parallel to z-axis, and we can draw line parallel to this line which will connect these two ends. So we can draw line like this. So in this way we can draw top view in xz plane. Now we have to complete this rectangular block. So for that we have to draw vertical lines from these corners. So we can make roll and draw parallel to y-axis, and we can draw vertical lines from this corner as well as from this corner like this. So draw vertical lines. Now we can complete the backside rectangle. So we can connect these two ends which is parallel to x-axis like this. Then we have to draw lines at each corner. So we can draw line at this corner and this corner like this. So always remember, for each corner we have to draw a line. Now here these corners are at back side of the object. So we can erase these lines. So this will be the final isometric view for given rectangular block. Now we can give the dimensions for this isometric view. So this vertical length it is 60 mm. Then this length it is 40 mm. Then this length it is 20 mm. So we can give the dimensions accordingly. So this front view it is on right side of point O. So here we have got front view which is on xy plane, and here is the top view which is in xz plane. Now let us take another example. Now object is similar. In earlier example this small rectangle was in top view and this large rectangle was in front view. Now if you try to visualize, it is also rectangular block, but its orientation is different. When we look at the object from front it is small rectangle, and when we look at the object from the top side then it is large rectangle. So it will be like this. So this is the front view and this is the top view. So this front view it is on left side of point O. So from O on left side there is YZ plane. So this is the front view and this is the top view. So this top view will always in XZ plane, whereas front view will be either in XY plane or in YZ plane, depends upon position of point O. So similar to previous case, we can draw isometric view step by step. So this is the front view rectangle and this is the top view rectangle, and we can complete the rectangular block like this. So here these edges are at back side, so we can erase these edges and we will get final three-dimensional isometric view. Now we can give the dimensions 40 mm, 60 mm and 20 mm like this. Now let us see effect of change in origin O. Just now I explained the isometric view for this given front view and top view. It will look like this. Now suppose this origin O is shifted on this side. So let us take same example, but here origin it is shifted on right side. So let us see what will be effect of change in origin O. So if we draw isometric view for this case, then it will look like this. So this front view which is on left side of point O, so this front view rectangle will be on left side, that is in YZ plane. Whereas in this case, this front view it is on right side of point O, so this front view will be on right side of point O, that is on XY plane. And when front view it is on left side of point O, then front view will be in YZ plane. In both the case, top view is in XZ plane. So if front view it is on right side of point O, then front view will be in XY plane, and when front view it is on left side of point O, then front view will be in YZ plane, and top view will always in XZ plane. Now let us see effect of change in orientation of the object. So for this example, position of O point is same, but this front view is similar to previous top view and top view is similar to previous front view. So in this case, we will get isometric view like this. So here this is the front view which is on left side of point O. So in isometric view also we will get front view on left side, that is in YZ plane, and in all the cases top view will be in XZ plane or parallel to XZ plane. Now let us see effect of change in given view. In this orthographic views, instead of front view and top view, front view and side view is given to us. So its isometric view is similar. So in both the case, front view it is on left side of point O. So similar to previous case, here also we will get the front view on left side, and this is the right hand side view. So on right side of point O, we will get the right hand side view. Now suppose instead of front view and right hand side view, front view and left hand side view is given to us, then in that case our isometric view will be like this. So here we can see this front view it is placed on right side of point O. So front view we will get on the right side of point O, and left hand side view we will get on left side of point O, that is front view will be in XY plane and left hand side view will be in YZ plane. So always remember, the right hand side view will be on right side of point O, that is in XY plane, and left hand side view will be on left side of point O, that is in YZ plane. Let us take another example, and question is like this: draw isometric view from given orthographic views of object by first angle method of projection. So this is the orthographic view by first angle method of projection. So this will be the front view and this will be the top view. So if we try to visualize three-dimensional object for this given front view and top view, then it will be cylindrical block. So when we look at the cylindrical block from front, it will look like rectangle, and when we look from the top, it will look like a circle. So we can easily visualize that it is the cylindrical block. So we can draw its isometric view. For that, draw one horizontal line. On that horizontal line, by using protractor, draw 30-degree line on right side, 30-degree line on left side, and 90-degree line, that is vertical line. These are the isometric axis. In earlier example, we have seen how to draw isometric view for rectangular block. So front is rectangle similar to previous case, and top view is a circle. So for top view we can make a box, so it will be a square. As diameter of this circle is 40 mm, so it will be square of 40 by 40. So first we will draw a isometric box for this rectangular front view and square top view. So isometric box, it is not final isometric view. So while drawing isometric box, we have to draw by thin lines or faint lines. So as I explained earlier, we can start from the front view. So from point O, there is horizontal line on right side. So in isometric view, on right side of point O, there is x-axis. So we can measure 40 mm distance and we can draw a thin line of 40 mm length. Then from O point, there is vertical line of 60 mm length. So we can measure 60 mm distance and we can draw a line of 60 mm length. Now we can draw this line, which is 40 mm length and which is parallel to this line. So this line we have drawn along x-axis. So we can make roll and draw parallel to x-axis, and from this end we can draw 40 mm length line. Then we have to draw this line. So this line, it is 60 mm, which is parallel to this vertical line. So here this vertical line, it is along y-axis. So we can draw line parallel to the y-axis and its length will be 60 mm. So this is the front view rectangle. Now we can draw top view square. So when we look at the object from the top direction, then as this is the point O, from O this will be the right side and this will be the left side of point O. So from point O on right side, we have to draw 40 mm line. So while drawing the front view rectangle, we have already drawn this 40 mm length line. Now from this O on left side, it is 40 mm. So along Z axis, we can measure 40 mm distance and we can draw a thin line of 40 mm length. Then this line, so this line, it is parallel to this line which is drawn here. So we can make roll and draw parallel to x-axis, and from this end we can draw a line of length 40 mm which is parallel to x-axis. Now next we have to connect these two ends like this. So we can make roll and draw parallel to z-axis and we can connect these two ends. Now we have to complete the rectangular box, that is isometric box. So from these corners, draw vertical line and its length is 60 mm. Similarly, from this corner, we can draw vertical line of 60 mm length like this. Then we can connect these ends like this. So this is the isometric box for given front view and top view. So to draw isometric view of any object, first we have to draw isometric box like this. And to draw this isometric box, we have to draw a rectangle for front view which includes the front view and another rectangle which includes the top view. And for this rectangular front view and top view, we can draw isometric box like this. So to draw isometric view of any given problem, we have to draw isometric box like this. So here in front view, already rectangular front view is there. So it is not necessary to draw the another rectangle. But suppose if it is not rectangle, then we have to draw a rectangle in the front view such that which enclose the front view. And here in top view also we have to draw the rectangle which enclose the top view. And from the front view rectangle and top view rectangle, we can complete the isometric box like this. Now here front is rectangle, top view is the circle. So we can visualize this three-dimensional object will be the cylindrical block. And the orientation of that cylindrical block is vertical. So this top view circle we have to draw on the top side of this isometric box. And this circle will not be circle in isometric view, it will be like ellipse. So there is 4 center method to draw this circular part in isometric view. And in 4 center method, first we have to draw the rhombus of length is equal to diameter of the circle. So here diameter is 40. So we have to draw 40 by 40 rhombus. And lines of this rhombus will be parallel to XYZ axis. That is isometric lines. After drawing the rhombus, we have to locate the midpoints of each lines of the rhombus. So this length of this line is 40 mm. So we can locate the midpoint at 20 like this. So if you look at this angle is 30, this angle is 30. So this angle will be 120. And this is also rhombus. So this angle is also 120 and this angles will be the 60 degree. So this top rhombus will be parallel to this bottom rhombus. So angles will be the same. Out of these 4 corners, this 120 degree it is the large angle and 60 degree is the small angle. So from the corner of the large angle, we have to connect the midpoints of the opposite line like this. So this is 120 degrees large angle So this side and this side is the front side or opposite side. So from this large angle we have to connect the midpoints of the opposite lines. Similarly, this also large angle. So from this we have to connect the midpoints of the opposite line or front side line. After this we can look at the four centers. So this will be the center C1, this will be the center C2. Means large angle corners will be the center C1 and C2, and the intersection of these lines, it is C3 and C4. So C1, C2, C3, C4 are the four centers, and by using these centers we have to draw the four arcs which will form the ellipse. So by using compass, or it is also called as a rounder, take C1 as a center and radius is equal to this much. Draw arc like this. Similarly, take center C2 and same radius and draw arc like this. Then take C3 as a center and radius is equal to this much and draw arc like this. Then take C4 as the center, same radius, and complete arc like this. So in this way we can complete circular part in isometric view. So it will look like a ellipse, and we have drawn this circular part by using 4 center method. Now as this is the cylindrical block, at base side also there will be circle. So we can repeat the same procedure for this rhombus, or here in this case the diameter of top side and bottom side will be same, so we can just shift the centers by 60 mm height. So this base circle, it is at 60 mm in downward direction. So we have drawn this top circle. Similarly we can draw this bottom circular part which is at 60 mm distance. So instead of repeating this 4 center method for this rhombus, as diameter of this top circle and bottom circle is same, we can just shift the centers by 60 mm distance in downward direction like this. So without repeating this procedure we can directly get the centers. So by using compass we can take this as the radius, take C1 as a center and draw a arc like this. Then by using same radius, take C2 as the center and draw arc like this. Then in compass, take this as a radius, take C3 as a center and draw a arc. And for this arc we have taken this as a center. So take C4 as a center and same radius and draw a arc. So in this way we can complete the circular base. Now as this is the cylindrical block, to draw its vertical surface we need to draw the tangents. So by using scale we can draw the tangent on left side as well as tangent on right side to these circles. So this will be the cylinder. Now this half portion of the circle, it is at back side, so we can erase that back side and only a half circular part will be visible. So in this way we can complete the isometric view of the cylindrical block. Now suppose orientation is changed. So front view is the circle and top view is the rectangle. So this will be also cylinder, but its orientation is changed now. So let us see how to draw isometric view for this front view and top view. So as I explained earlier, we have to draw a rectangle or square in which that front view will occupy. So here it is 40 by 40 square for the front view and top view it is 60 by 40 rectangle. So in earlier case height of the front view was 60. Now in this case height it is 40, so it will be reduced. So this front view it is on right side of point O. So on right side of point O we will get the square for the front view, that is 40 by 40, and top view will be in XZ plane having dimensions 60 by 40. So in this way we can complete the isometric box. Now here this circular part it is on right side of point O. So for this rhombus we have to draw the circular part which will look like ellipse in isometric view. So by using 4 center method, first we have to draw a rhombus of 40 by 40 which already drawn while drawing the isometric box. Now we have to locate the midpoints, and this is the small angle, this is the large angle. So from large angle we have to connect the opposite midpoints. So from the large angle we can connect this point and this point. So this is also large angle. So from this corner we can connect midpoints of the opposite sides. So this angle and this angle are acute angle, that is smaller angles. So we will not connect the midpoints of the opposite side from this angle. Then this large angle will be by default centers, and by using this 4 center, this center C1, C2, C3 and C4, similar to previous case, we can draw a ellipse by using 4 arcs. Similarly, we have to draw circular part at back side also. So here also we can shift these 4 centers by 60 mm distance and we can draw circular part. And to draw the curved surface, we have to draw the tangents like this. So for backside circular part, this edge will be at backside, so we can erase that. So this is the isometric view of the cylinder for given front view and top view. Now suppose this origin is shifted on right side. So this circular part will be on left side of origin. So this circular part will be on this side. So it will look like this. Now this is the next example. Here instead of full cylinder block, it is half cylinder block. So this is the half cylinder block. Now if you draw a rectangle for front view, it will be 40 mm width and 20 mm height. So if you draw a rectangle which encloses the front view, it will be like this. So its length it is 40 and height it is 20, which is equal to radius of the circle. So dimensions of isometric box will be reduced like this. In previous case, height of the isometric box was 40. So now here it will be 20 because height of the front view is 20. So here front view it is on left side of point O. So on left side, that is on this plane, YZ plane, we have to draw the circular part. So we have to draw the half circle here. And we can draw by using 4 center method. So we have to follow the procedure same as full circle, but we will draw only half part. So for 4 center method, we have to draw the rhombus equal to diameter of the circle. So this length is 40, but this is 20. So we can extend this up to 40 and we can complete the rhombus like this. So this is the rhombus of 40 by 40. Now we can locate the midpoints of each side of the rhombus, and this is the large angle and this is the small angle. So from large angle, we have to connect the midpoints of the opposite sides like this. So this is also large angle, so we can connect the midpoints of the opposite sides. And by using 4 center method, we can draw a circle. Similarly, we can draw a circle at back side by shifting the 4 centers. Now here, it is not required to draw the upper half circle, so we can erase that. So to draw the lower half circle, we need this center and this center. It is not required to use this center and this center to draw the upper half circle, or if we draw, then we can erase that. Then we can draw this horizontal line. So we can draw this edge. So this edge means it is here like this. Now similar edge is there at back side also. So at back side also we can draw this edge. Then we can draw these edges like this. Now this is the cylindrical part. To visualize the curved surface, draw a line which will be tangent to this circular part and this circular part like this. Now if you try to visualize, this part will be at back side, so we can erase that. So this will be the isometric view for the half cylindrical block. Let us take next example. Question is like this: draw isometric view from given orthographic views of object by first angle method of projection. So orthographic views are given as per first angle method of projection. So this will be the front view and this will be the top view of the object. So first we will try to visualize this object. So this is the square of 40 by 40 in top view, and if you take the projection in front view, there is a horizontal line at base of 40 mm. So this square, it is at base like this. So this is the square of 40 by 40 and it is at bottom side in the front view. Now this inner square, which is of 20 by 20 mm, and if you take the projection of this inner square in the front view, then here it is the horizontal line of 20 mm. Means this inner square, it is at 60 mm height from the bottom square. So this is the bottom square of 40 by 40, and from this bottom square at 60 mm height there is top square of 20 by 20 mm dimension, like this. And this inclined line in the top view look like tapered in the front view, and these four lines connect the four corner of the top square to the bottom square. So we can connect the lines like this. So in this way we can visualize the object. So this object, it is the frustum of square pyramid, means the square pyramid which is cut at the 60 mm height, and we have to draw the isometric view. So I will explain step by step. So first we have to draw horizontal line, and by using protractor we can measure 30-degree inclination and draw line on right side, 30-degree line on left side, and 90-degree line, that is vertical line. So this XYZ are the isometric axis. So this is the O point in the front view, and this is the O point in the top view. So that O point will be here in the isometric view. So first we have to draw the isometric box for the front view and top view. So front view rectangle, it is 40 mm length and 60 mm height, and top view it is square 40 by 40. So for this 40 by 60 front view rectangle and 40 by 40 top view square, we have to draw the isometric view. So to draw the isometric view, we can see from O on right side there is 40 mm long length. So from O we can measure 40 mm distance and we can draw a line. Then from O point vertically upward we have to draw 60 mm line. So from O we can measure 60 mm distance and we can draw a thin line. Then this line is parallel to this line, so we can make roll and drop parallel to x-axis, and from this edge we can draw a line equal to 40 mm. Then this line, it is parallel to this vertical line, so we can make roll and drop parallel to y-axis, and we can draw a vertical line of length 60 mm which will connect these two ends. So when we look at the object from the top direction, this is O point, so this will be the right side of O and this will be the left side of O. So from O on right side there is horizontal line which we have already drawn while drawing the front view along x-axis. Then on left side it is 40 mm. So from O to left side it is z-axis. So along z we can draw 40 mm length line like this. Then this line, it is parallel to this line. So we can make roll and draw parallel to x-axis, and from this edge we can draw a line of 40 mm length. Now we can connect these two ends. So this line is parallel to this line. So we can make roll and draw parallel to z-axis and we can draw this line. Now we can complete the isometric box. So draw vertical lines parallel to y-axis and its length will be 60 mm. Then connect these corners. Like this. So this is the isometric box. So this front view rectangle, it is 40 by 60 and top view it is square 40 by 40. Now if you look at the top view, we can draw this square 20 by 20, and this square it is at top side, means in this plane we have to draw that square and it is at center. So this plane it is 40 by 40 and we have to draw here 20 by 20 square. So to draw this square we have to skip 10 mm from right side, similarly from left side. Similarly on this edge also we can skip 10 mm from this side, 10 mm from this side. Now from this point we can draw a line parallel to this. So draw a line parallel to z-axis. Similarly from this point also draw a line parallel to z-axis. Now to complete the square box we have to draw a line from this point. So we can make roll and draw parallel to x-axis and draw a line which will connect these two lines. Similarly on this side. So in this way we can complete the top square. This bottom square we have already drawn here. Now we can draw lines which will connect this top square with the bottom square. These lines. So we can connect the each top corner to the bottom corner like this. Now we can make the edges of final object dark or thick like this. So this is the final isometric view of the given orthographic views. So we can give the dimensions. Vertical height it is 60, this length 40, and this top square it is 20. So this is the final isometric view for given orthographic views. Now you can check your understanding about isometric projections or isometric views by attempting the quiz. So I have given link of that quiz in description of this video, so you can attempt the same. Thank you.